Welcome back to Topic 12 for Algebra 2, Number of Solutions to Systems of Equations. In this video, we're going to solve 3 different examples of systems of equations and identify what kind of solutions they have. In our first example, we have y equals 2x plus 5 and 4x minus 2y equals negative 10. Now, I very specifically did not put actual instructions here besides just to obviously solve the system of equations because I want students to get comfortable with identifying which method they think would work best. Since we already have a variable isolated here, the best way or the best method to solve this is with substitution. So we're going to take this entire quantity because it is equivalent to y and plug it into y into the second equation. So we'll get 4x minus 2 instead of y. We're going to write the first equation, 2x plus 5 equals negative 10. Now we can just solve this just like we learned with solving linear equations in topics 1 and 2. So we're going to distribute and we get 4x minus 10 equals negative 10. If we simplify on the left-hand side, 4x minus 4x is 0, and we get negative 10 equals negative 10. Now if we want to group our constants on the same side, we can add 10 from the left side, move it to the right, and we end up with 0 equals 0. Now this, if we ever have 0 equals 0, if we think back to topics 1 and 2, we know that this means that there is an infinite number of solutions. And I want to show you why. So we have this first equation here, y equals 2x plus 5. What I want to do is take the second equation, which is 4x minus 2y equals negative 10. Now this equation is written already in standard form, but what I want to do is convert it to slope-intercept form so we can compare the two. So we're going to isolate our y variable, and we're going to subtract 4x from both sides. On the left-hand side it reduces. We get negative 2y equals. Now I can rewrite it as negative 10 minus 4x. But as long as you keep the sign that is in front of it, to the left of it, alongside with it, let's have it look a little bit more like slope-intercept form, so negative 4x minus 10. You can always do this as long as you just keep the sign that's in front of it alongside with it. If you don't see a sign, then it is positive. So right now we have negative 2y equals negative 4x minus 10. We want to isolate that y, so we're going to divide by negative 2 on everything single side. And we end up with y equals negative 4 divided by negative 2 is positive 2x, and negative 10 divided by negative 2 is positive 5. Which, if you look at the first equation, they are the same equation. In other words, they are the same line. So the lines, graphing them, if we graph them, they would be on top of each other. So if we graph the first equation and then the second equation we write on top. So if we think about all the possible intersection points, all the places where those lines touch, it would be infinitely many number of places because the lines would be on top of each other, they'd be touching all of the same points. Let's try this second example. We have negative 2/3 x minus y equals negative 1, and 2x plus 3y equals negative 3. With this problem, I want you to think about elimination. Because we have this negative y here and this positive 3y. So all we really need to do in order to, let's say our goal is we want to get negative 3y and we want to get positive 3y so that we can cancel the y variable and isolate the x variable. So I'm going to multiply the top equation by 3 and then I'll just rewrite the bottom equation. So this is really 3 over 1. If we have negative 2/3 times 3 over 1, we end up getting negative 6. We distribute, so we distribute to all of them. Negative 6/3, which is the same thing as negative 2, and then x. Then we have 3 times negative 1, negative 1y I should say, which is negative 3y, and 3 times negative 1, which is negative 3. And then we can rewrite that second equation again, just the same. Now here we're going to add vertically our y variables we're going to cancel out. Then we have negative 2x plus 2x. This gives us 0x, or just 0, because remember 0 times anything is 0. And the negative 3 plus a negative 3 is negative 6. But, however, 0 does not equal negative 6. This is false. So, this is no solution. The lines do not cross at any particular point or points. So in this case, if we were to graph it, the lines are parallel. Now for our final example, here I'm going to provide you with a graph. So I want you to use graphing. Our first equation, we have y equals negative 1/2 x minus 1. Already in slope-intercept form, so we're going to plot our y-intercept, which is negative 1. And then our slope is down 1 to the right 2, down 1 to the right 2 off the graph, or up 1 to the left 2 if we want to extend the opposite direction. Then we can connect our line, and that was the first one. If we want to do the second one, also in slope-intercept form, so we have negative 4 as our y-intercept, but this is a positive slope of 1 over 4. So we get this, or over here, or down 1 to the left 4. So right now this actually crosses at a point. This crosses at the point 4, negative 3. So we have one solution, because there's only one place that these two lines cross. For lines, you can either have it crossing one time, no time, or infinitely many times. There is no like in between there. You don't have it crossing twice, because then we wouldn't be dealing with lines, we'd be dealing with curves. Okay, so in summary, if we have one solution, then that means we will have different slopes. Here we could have the same y-intercept, or we could have different y-intercepts. If we had the same y-intercept, that would be where our solution is. But they have to have different slopes in order to have one solution. This is called consistent, because there is a solution, and independent, because there's specifically one solution. If we have infinite solutions, here we would have the same slope and the same y-intercept. And this is because we're dealing with the same line. So they're going to have the same slope, same y-intercept. So this is called consistent because there is a solution, and dependent because there are infinitely many solutions. Last but not least, we have no solution. So they have the same slope, because the lines have to have the same slope if they're parallel, but different y-intercepts. So they will never cross. So in other words, these are parallel lines. And these are the same line. So, because there is no place where the lines will cross or touch, there is no solution is called inconsistent. And that was all she wrote. That was topic 12 for Algebra 2 on number of solutions to systems of equations. Thank you for watching.